Number 5. Green doesn't show up well, though.
It's okay.
It is? Oh, okay. We're going to play with green for a minute. What effect will reducing the volume of the reaction vessel at constant temperature have on the following equilibrium? So, okay, we're at I got to write the equation. Where was the? Okay, fine. A gas plus B gas. Okay, so okay, so what is this question asking? What type of what principle is this?
This is,
No.
but what it's, I don't know what it is, but what it states is if atoms,
Volume,
if molecules
pressure.
have the ability to, if they have the room, when you pressurize something, if there's 2 moles of something, it's going to force those 2 moles to turn into 1 if it's pressurized.
No. There's a principle. You're working too hard.
We use
Okay.
a constant. We use a pressure.
It's,
VP
Yeah.
over V. or
no, there's.
something like
That's I use the word principle.
The
Oh,
Chatelier.
Chatelier.
Yeah, that French
that.
tube, as we say in Oxnard. It's like that French tube. Okay, the Chatelier's principle. We're taking an equilibrium and we're subjecting it to a stress. Okay, so I take
Right.
this particular reaction. So what we have to do is write out the mass action law for this reaction. And the mass action, this would be a Kp, is equal to, and let me get a pen
CQ,
that actually writes, the pressure, and I gotta get a pen that actually writes, the pressure of C cubed over the pressure of, partial pressure of A times the partial pressure of B. And now consider what would happen, because well, the Chatelier's principle, recall, we could go all the way back and do it with free energy, but that's probably further than we need to go. We can just use the mass action law at this point. That's a closer, easier approach. So the question is, if I increase the pressure on the whole container, what's going to, the pressure of A is going to increase at the same rate that the partial pressure of B does, right?
and C.
But
Yeah.
and the pressure of C is going to increase at the same rate as that. But since
Cubed.
the pressure, the C term in the numerator is cubed,
It's going to pressurize way.
Yeah.
this is going to grow much faster in the mass action law, and therefore, since PC term is cubed, this increases then PA and PB terms. And therefore Q is gonna be greater than or less than.
Greater than?
Since it's in the numerator, Q is greater than K. And now, yeah, in order for it, so Q is greater than K. At this point, I want, maybe we should fall back on the scratch paper for a second. Because sometimes we're going to, well, what am I going to have to do to make that Q restored? I want Q to get, I want it to restore the equilibrium value. How can that happen? What's the reaction has to go which way?
To the left.
To the left, which is going to reduce the C term.
Right.
And so, therefore, reverse process favor. And now I'm going to talk a little bit about what we can, and I want to tether this to where to what we started out with, the underlying thermodynamics, and the appropriate expression in the underlying thermodynamics, which we derived, was with respect to the Gibbs free energy and spontaneity. Spontaneity determines which process is going to be spontaneous, and the appropriate one for Le Chatelier's principle is the delta G was equal to, anybody? RT natural log of
Q over K.
yeah. And the condition for spontaneity is that delta G be less than 0. And that's going to be true in this case. Q is greater than K, therefore this is going to be positive. And so that means that delta G will be negative for the reverse process. So the reverse process is spontaneous. That's what I meant when I said it's favored. Whereas if Q was less than K, this is negative, the forward process is favored. And if Q is equal to K, this is 1, and the log of 1 is 0. We're at equilibrium. Okay? So I just want to keep that fresh. It's going to be important on the final. Okay? Any other questions about that?
So you said, so this Q over K is going to be positive, so RT natural log, that is going to be negative?
Well, if Q over K is positive, it's greater than 1, the natural log of that is going to be positive, so it's the reverse process that's going to have a negative free energy.
Let's go back to.
Yeah, there's a driving force, the Gibbs free energy, which drives every process, is going to drive it, the reverse process. It's going to be driven towards until it reaches equilibrium where Q equals K. Okay, so it's just a restatement of Le Chatelier's principle. So, which we already could get just by inspection from the mass action expression. So the most immediate and simple way to do this is just look at the mass action expression. But then might as well just talk about this since we're here. Yeah. What?
I was going to say that it's just common knowledge that when you got pressure, it's going to, the more moles are going to flow to the side where there's less moles.
That's conceptual.
I know that's undermining everything.
Well, no, it's not undermining anything. In fact, whatever works conceptually is good. The question is, what we have to be able to do is question everything. And I got to go back and think about that approach and find out if I can find an exception to that. Then that means it's not true in every case, and so that means that wouldn't be a good approach.
Okay.
The only time something is going to be, if you have something that survives all of your possible assaults, and you want to question not only everything that I say, because I like to question, when I question everything, I question myself more than anything. And yet you have to be able to question yourself without undermining your self-confidence. And so,
I'm not sure. There could be
there's a
exceptions.
balancing act here. I want you to question it, and if you have an approach that works, that is actually better, because it works. But you want to continuously, the caution is, question what you're doing and try to knock yourself out of the water, which is the hardest part of the process. When you're doing all this work, particularly in the laboratory, you're trying to prove something and you've got it and it worked. Now we're ready to go share our information with the public. The first thing you have to do is knock yourself out of the water, because
That's what they're gonna
to
do.
spare yourself the embarrassment of being publicly geschmoiled. Because you'll be up in front of a room full of people and they're just going to have fun. It's a feeding frenzy. It's something to watch. And you're on the menu. So, personally, I'd rather knock myself out of the water than have somebody else do it. And so that's the cautionary part. But absolutely, because
No, you're right, though.
you arrived at that by thinking about it and questioning. So keep that up. And now that you've got your approach, I want you to think about that approach and try to knock it out of the water. I'll do the same thing and see if I can knock it out of the water. I'd rather have you,
I'm gonna check it out.
yeah, check it out, yeah.
If we're just talking about moles,
Yeah.
if you had 3 partial pressures for the reactants
Yeah.
and the cubed partial pressure for the product, is there some way to say that
You mean it
those-
was partial pressure A, partial pressure B, and partial pressure C?
Yeah.
Or if I had 3 reactants and just
Then you have 3 moles
react-
on one, 3 moles on the other.
Yeah,
Wouldn't-
Did that change?
Would
What
the-
changes it?
Wouldn't the cubes still grow more quickly? than three?
because this term is cubed.
Yeah.
These are not.
Yeah.
Although, because we know nothing about the magnitude of them.
But
So
isn't there?
they could be, with PA equals PB and P equals PC, and we had PD, which was cubed on the top, and PA, B, and C are all equal, then I've got PA, B, and C, that's P cubed. Yeah, that's a good point, but we don't know if they're equal, and they
True.
may not be.
You can't cube them if they're not equal.
Yeah, and so, though this is atmospheres cubed, the units, that would give us, I would still say that this term itself is growing faster than any of these individual terms. And so I still would hold that this would be so. Okay, that's a very good question. I like that. Think about it yourself, and we can come up with some examples and do the same thing we were just talking about with Steve. Okay? Any other questions? Okay, let's move on to.